Hi friends, here we are in Algebra 1 looking at Chapter 1, Section 2, Order of Operations. So our only vocabulary term today is order of operations, and what that refers to is the order in which we need to attack any math problem ever when we have one that we need to deal with. So it tells me the order in which to perform different operations. So let's take a look at what that is. The first thing we're supposed to do is to observe any parentheses, or another way of talking about parentheses is any grouping symbol. And so that could look like you might have a pair of parentheses, you might have a bracket, or you might have a fraction bar, which actually works as a grouping symbol. And we'll talk about that more very soon. Next, we should address all exponents in our problem. Then we should do all of the multiplication and division in a particular problem. And this is important. Multiplication doesn't supersede division, and division doesn't supersede multiplication, meaning you shouldn't do one before the other. You're just going to go from left to right in your problem, right? You're just going to go from left to right, doing multiplication and division as it comes up. And the next thing you're supposed to do is addition and subtraction. And again, neither of these supersedes the other. You just go from left to right at the end of your problem, cleaning up and doing the addition and subtraction that you have. So parentheses, do anything that is being grouped together. Exponents, deal with whatever exponents are in your problem next. Finally, well, not finally, next do multiplication and division from left to right, and then addition and subtraction from left to right will be the final step. Let's take a look at some examples to give us some practical practice using order of operations. If you're unfamiliar with order of operations, I would suggest you write down a little, a memory device just to get it together. So you, anytime you do a problem, so you can keep it in mind. So PEMDAS, PEMDAS, or please excuse my dear Aunt Sally, is the way I was taught it back in the day. However, you can do what you need to do, but make sure you remember that this is probably a decent way to keep in mind the order of operations and what thing needs to supersede what thing goes before what. All right, so this problem has no parentheses, so I don't need to think about that. There are no exponents here. I don't need to think about that. The next thing is multiplication and division. So the temptation is to treat this like a reading problem, right? We read from left to right, and we go with what we see as we see it. But in mathematics, we have to be specific about what happens. So since we're doing multiplication division, and that definitely supersedes addition and subtraction, we're going to deal with this portion first. So when I rewrite the problem, I've now taken care of the multiplication here. I get 6 plus 5. And at this point, I have done all that I could do, and now what's left is the addition and subtraction. There's only addition here, and I'm supposed to do that from left to right as well. So when I do that, 3 plus 6 gives me 11, plus 5, no it doesn't, just lying, sorry about that. 3 plus 6 gives me 9, 9 plus 5 more gives me 14, so 14 is my answer. And the funny thing about this is if you had done it differently, let's take a look over here. I'm going to pull up a red pen to suggest danger. Don't do this. So suppose you took 3 plus 2 and made it 5, and then did 3 plus 5, and 3 plus 5 is 8. You would have gotten 40, right? So the order does matter. The intention of this problem is to get 14, and we want to make sure and do that by making sure that we follow the order of operations. All right, so let's take a look at this next example. Down here, we have, in part B, we have another situation. There is no parentheses, but there is an exponent. We need to handle this first. So that's the first thing we'll do. And so we've got 15 divided by 3. Notice I'm rewriting everything exactly the same way, except dealing with the thing that I'm supposed to in terms of the order in which I'm supposed to deal with them, the order of operations. 4 to the second power means 4 times 4, which is 16. The next thing we need to do is check for multiplication and division. And I see right here I've got division and multiplication. Neither one of these supersedes each other, so I just take it as it goes. They're equivalent. So I am going to go from left to right dealing with any division or any multiplication I see. So 15 divided by 3 is going to give me 5. Then I'm left with 5 times 5 minus 16. I'm going to deal with the next multiplication situation here. 5 times 5 is 25 minus 16 is what I have. And now the only thing less, I've dealt with parentheses, there were none. I've dealt with exponents, just one. We have multiplication, division, dealt with those guys. Now I've got addition and subtraction, so I'm going to subtract. 25 minus 16 is 9, and that's my final answer. Not too bad, right? Let's take a look at a couple other examples. Over here in example 2, we're looking at some grouping symbols. And so here we have parentheses, which is grouping something together. And here we have brackets, which is grouping all of this together here. And so, and we do have parentheses here, but this 5 is not being actually grouped together because it's alone. What you're noticing here is that this represents multiplication. So sometimes the parentheses, when it's around a single digit or around a number without any operations going on inside, really implies that oftentimes implies that there's going to be some multiplication happening, and as this is here. So this can be read 2 times 5 plus 3 times the quantity of 4 plus 3. So keeping in mind our rules for engagement, right? Anytime we're dealing with a math problem, we're going to keep this in mind. I'm going to come back over here and say, okay, I'm going to deal with the parentheses first. And so this is still 2 times 5 plus 3 times, now I'm going to do what's in the parentheses. 4 plus 3 is 7. So now I've got that. Now I've got two multiplication problems. I've got to multiply this, because there is no exponent, and I know multiplication and division supersede addition. So I'm going to deal with this now. So 2 times 5 gives me 10 plus 3 times 7 gives me 21. And finally, I can add or subtract. Only adding is left. 10 plus 21 is 31. And that's my final answer. Let's take a look at this guy. I'm going to scroll up a little bit. Scroll down rather. Okay, so I've got all of this stuff in parentheses. So I've got to deal with what's in the bracket. So the first thing I'm going to do is deal with what's in the bracket. And now within the bracket, I've got to deal with what's in this bracket. So I've got to do this thing here. That's the first thing I'm going to do. Watch the rewrite. Rewriting practically everything, but I'm going to rewrite this 30 divided by 6, because that's the first thing that I see in the deep parentheses inside. 30 divided by 6 is going to give me a 5, and that thing is being raised to the second power. And I got it like that, okay? Take a look, make sure I'm right. Sometimes I make mistakes. So the next thing I'm going to do is, so I've taken care of the parentheses. Well, actually, I haven't taken care of all the parentheses, right? I haven't taken care of all the grouping symbols. Here's this bracket here. I need to do what's in the bracket. So now that I'm inside the bracket, I'm still going to apply the order of operations, and the first thing I'm going to do is take care of this exponent. Does that make sense? I hope so. So I've got to do this thing, do what's in the bracket, but to do that I've got to use order of operations again. So within the bracket I get 5 plus 25, right? 25 plus 5 gives me 30. Hey, I handled what was in the bracket. I did it. Now I can deal with this 2 on the outside, and the only thing that's happening here is a bit of multiplication. So 2 times 30 is going to give me 60, and 60 is my final answer. Let's check out this next example. So we got the fraction bar, and the fraction bar is an interesting thing. The fraction bar is this guy here, right? And it means division ultimately. But when you see that in a problem, we could honestly put some parentheses around these guys. So the fraction bar implies a grouping symbol. So this implication will be taken as do what's on the top, do what's on the bottom, do that separately, and then you can bring it together and do the division or simplification, whatever you need to do. So if I'm going to do what's in the top first, take a look at that. 6 plus 4 to the second power. My rule, please excuse my dear Aunt Sally. Old habits die hard. Please excuse my dear Aunt Sally. When I have to do that, I'm going to deal with the exponent first within this parenthesis. So then I get 6 plus 4 squared is 16. Keeping my parentheses here, recopying everything so I can keep in mind what's going on. Next thing I'm going to do is simplify this top part by adding 16 plus 6 will give me 22. This is a great time for me now to turn my attention to the denominator, the bottom part of this fraction. So I've got 22 over, so I've got to deal with the 3 squared first before I can multiply anything, because parentheses, yeah, I'm dealing with it. Exponents, that's the next thing. 3 to the second power is 9 times 4. And now multiplication and division can come into play since I dealt with the only exponent there. 9 times 4 is 36. Now, we could divide it for a decimal, we get a decimal answer, but we have this beautiful fraction, let's reduce it. So the question is, what divides evenly into the numerator and denominator? Hopefully you're seeing that the number 2 goes in very easily to both of these numbers. So when 22 is divided by 2, we get 11. And when 36 is divided by 2, we get 18. And now that's our final answer. All right, keeping in mind that we're dealing with order of operations, I've got this here. Let's check out this problem. Example 4, evaluate an algebraic expression. So here's this algebraic expression. We remember from last time our vocabulary word from the first section, we had evaluate, which means to get a numerical answer. So we're going to do a little bit of substituting these variables for the numbers indicated. So I'm going to simply place the 7 wherever I see an A, and wherever I see a B, I'll put a 3, and wherever I see a C, I'll put a 5. Now, of course, if I just shoved a 5 next to it, I wouldn't be honoring the fact that this doesn't mean 40C, this means 4 times C, so I need 4 times whatever that number is, 5. So after I've replaced that, you know what I'm going to do? Order of operations, right? So order of operations tells me to first deal with whatever's in parentheses, so that's this here. And so since I'm dealing with that, I've got to now apply order of operations to everything inside. Let me make this look more like a multiplication and not a decimal. All right. So now that I've got that going on, 3 to the third power means 3 times 3 times 3, which I know to be 27. So now I've got 27 times 4, 27 minus 4 times 5. At this point, I'm still dealing with what is in the parentheses. So notice I'm just rewriting what's happening there. I'm going to do the multiplication here because that is the next thing on the list. 27 minus 20 is what I get. Now I can deal with the subtraction. I'm going to do a little arrow up here. So 7 squared minus 27 minus 20 is 7. So I end up with 7 squared minus 7. I'm not going to subtract. I'm not going to get 0 because I know that I've got to deal with exponents first, right? So 7 squared is 49 minus 7 is going to give me 42. And that's it. That's the answer, and that's my age. Let's go ahead and look at this next guy, example 5. So we're going to use an algebraic expression in this problem. So let's pay attention to the information given. The Pyramid Arena in Memphis, Tennessee is the third largest pyramid in the world. The area of its base is 360,000 square feet and it is 321 feet high. The volume of any pyramid is 1/3 of the product of the area of the base, which we use capital B for, and its height. The first thing we're asked to do is to write an expression that represents the volume of the pyramid. So I'm going to use the letter V for volume. And keep in mind that the volume of any pyramid, as it says here, is 1/3 of something, the product of the area of the base and the height. So that lets me know that this volume is equal to 1/3 something, and that something is a product. We remember product as a vocabulary word from our earlier section, product of two things, and those two things being the base, capital B, and the height of the particular pyramid, the area of the base, that's this capital B refers to. So now that we have this expression that we can use, I'm going to call it a formula, really, because it's letting me know what to do when I have these pieces, how to find the volume. I'm going to find the volume of the pyramid arena. And so what that means is we're going to have to do a little bit of substitution. So we're looking for the volume, and we know that it's going to be 1/3 of the product of two things, the area of the base, which is given as 360,000 square feet, times the height of that particular pyramid, which is 321 feet. So we're going to multiply these two guys together, and when we do so, we get quite a large number, 115,560,000 is the number that we get, and then we're going to multiply that by 1/3, which in essence we know means to divide by 3. And when we do that, we get 38,520,000 feet cubed, because we're talking about volume. I hope that was helpful, and I hope that made a bit of sense. Let me know if you have any issues, troubles, setbacks, or problems. We can talk about it. And until we meet again, go ahead and try some of those problems on your assignment sheet. Take it easy. I'll talk to you soon. Bye.